Good evening, and thanks for joining tonight's TI Technology webinar hosted by Texas Instruments. Where tonight we're going to take a look at the ACT math portion and maybe see if it's actually getting a little bit harder. My name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI technology to make tough to teach, tough to learn concepts accessible to all my students. And with us tonight, we have Tom Reardon. Tom taught for many, many years in Ohio and currently is working for Texas Instruments. And Tom, is there anything else you want to add to what you currently do?
No, I'm just happy to be here. It should be fun.
Thanks. So, Tom, what are we going to do tonight?
So the agenda on the screen there is I'm going to give you about 15 to 30 seconds to think about possible solutions to an actual ACT question. I'm not going to give you enough time to solve it completely because I want to give you several ideas, but I do want you to be able to think about it a little bit. We'll solve the problems using both 84CE and TI-Nspire CX technology. The solutions without technology will be left out because this is about technology, though I'll talk about that a little bit more. I will repeat that, and then at the end of the webinar drawing.
Thanks so much, Tom. Anything more specific about what we can expect to be able to do at the end of the webinar tonight?
Those are pretty much the outcomes. It can use either platform to solve actual ACT questions, and that you can explore those solutions also.
So I know that you want to ask a little poll in the chat.
Yes.
We also have a little sort of side poll going that has 3 questions. But Tom, what do you want to ask everyone?
So what I'd like you to do right now in the chat, and I'd like all of you to answer, even though some of you don't like to do that. If you could type in, if you're primarily an 84 user, just type in 84. If you're primarily an Inspire user, you can just put a capital N. And if you're both, you feel comfortable with both. So 84, N for Inspire, or both. And that way I can see what my crowd is tonight. So thank you for answering that.
So we are going to be using that chat window tonight, as Tom is already using that and engaging with that. We are going to be using the Q&A window. If you have any questions for Tom, feel free to use that Q&A window and get those questions asked. I know Tom will do his best to get those questions answered. And as a reminder, this session is being recorded, and we'll provide a link to the event certificate of attendance at the conclusion of the webinar. So Tom, as you're kind of getting things started and sharing your screen, I'll kind of let you know, scrolling through here using my best estimation skills, I would say we're probably looking at 70 to 80% 84.
Okay. Okay.
Maybe higher.
Okay. And there's some of them that are both too, right?
Yep.
Okay.
Thanks everyone for being patient. It looks like we're having a technical issue with Tom sharing a screen, so just give me 1 second.
Mike?
There we go. I can hear you, Tom.
I'm listed twice, but somehow I got thrown out. So
Yep, I got you. I'm gonna kick out the bad Tom Reardon.
That would be both of us. Okay, so sorry about that. I don't know what happened. All right. So we good now? Can
All
hear?
good.
All right. Sorry about that, everybody. All right, so this is our topic tonight, and this is the link that will get you all the problems and all the solutions in both 84 and Inspire. Okay. In fact, Mike, if I don't know if you have that, could you maybe even put that in the chat? It will be up many times during this, though. It's all lowercase. It is case sensitive. Okay. All right, so I like to start off with a quote wherever I am, and so this is the one I picked today. With every mistake, we must surely be learning, and many of you might know who that is. It's a Beatle. And this one I've used before, but I still like it. The human brain is awesome. It functions 24 hours a day from the day we are born and only stops when we are taking an exam or fall in love. So I thought that was a good one. Hopefully you like that one too. So tonight the focus is on harder problems on the recent ACT exams and how to use graphing technologies to solve them. Again, as I mentioned before, the algebraic solutions are left to you because you know them, you have them. But I'm going to focus on the technology. However, I want to strongly mention that I want my students to be able to do these algebraically, what I say call by hand, and use technology as a learning tool, or as if I just kind of forget something or whatever. But remember, on this high stakes exam, we want them to be able to use graphing technologies effectively, efficiently, effortlessly. Okay. And I will mention that currently I volunteer to teach ACT math prep sessions at 2 high schools here in Columbus, Ohio on Wednesdays. So I'm definitely still reaching students and having fun with the ACT. Again, this is the link. I think that Mike put it in the chat. And so if I go too fast, keep in mind the solutions will be there. Okay, this is that link right here. I'll also tell you what the rest of this is. I do want to mention some of you might have come to see Jeff McCullough, and maybe that's the only reason you came, and I don't blame you, but Jeff was unable to attend tonight, so you're just stuck with me. All right, so let's go ahead and get started. I plan on doing the 84 first and then showing the Inspire also. Again, my plan is to give you about 15 seconds to read the problem and start to think of a solution, okay? And then I'll come in. So go ahead, you've got 15 seconds. All right, 15 seconds does go by pretty quickly. All right, so this one, I would hope students wouldn't do it by hand, but you might want to, okay? So unfortunately, a lot of them would multiply the 20%, the 20%, and the 50%, and get an answer that might be there, and it would, of course, be wrong. So, so for here, what I would suggest is it says the price that resulted from these 3 decreases was what percent less than the original. So what I like to do is go with what was still there. So if it's decreased by 20%, it's now there by 80%. And then decreased again by 20% would leave me 80% of that. So I'll multiply that by 80%. And then multiply that by 50%. And that is how much it is now. So what we need to do is take 1 minus that to get the percent, which would be 68%. So here I'm using technology to do the calculations for me. I'm doing the thinking, but letting the calculations go there. You'll be able to see that This is how I did it with the 84. And on Inspire, it would be done in a very similar way. I just multiplied 0.8 times 0.8 times 0.5 and subtracted it. Or I could have done 1 minus that altogether. It doesn't matter how that would be done. So those two aren't very different. You'll notice this is a number 52. So this would be a much more difficult problem than others. Oh, I forgot to mention, on the ACT right now, 60 questions, 60 minutes. That's 60 seconds per question, and that is wrong. If you have your students think that, that's not going to work. I like to think of it as a 30, 60, 90. That was kind of a quick way of summarizing this. So for the first third of the problems, I would suggest that your students spend about 30 seconds on the first third, 60 seconds on the next third, and 90 seconds on the third third. And this would be a 90-second. So that's just not a hard and fast rule, but a good one to shoot for. All right, this one is from June 2022, number 15. These are actual ACT questions, by the way. ACT has given us permission to use them, okay? And for this one, most of us would draw a right triangle and know about the 3, 4, 5 triangle. But I came up with this. I'm curious if you guys like this or not. So I have the calculator. It is in radian mode, okay? And so what I'm really trying to do is find the cosine when I know the sine or when I know the tangent. So I'm going to say I want to find the cosine when the inverse sine is 4/5. So here's where I'm using the sine of the inverse cosine, and we do that sometimes in our trig classes, but not very much in our geometry classes. Okay, but this is how I'm talking through it. And I'm getting 0.6, which isn't one of my answers. So I'm going to use alpha y equals to show the fraction to decimal, decimal to fraction, and there's my 3/5. I could have also done the sine when the tangent is 4/3 and gotten a similar result. This is a little bit maybe beyond what you might want students to do, but I still think it's cool. And somebody said it was cool, and whoever said it was cool, then I will show you a Pez. Okay, thank you, because that's why I picked 15, even though it's a small number. I think it's kind of a cool way to do this problem. So again, you could do it cosine of the inverse tangent, and then on Inspire, in case you're not familiar with Inspire, if I wanted to do the cosine, all of the trig functions, inverse and regular, including the reciprocal functions, are all under the trig button. And so you would just use those buttons to get that. So let me just stop there for a minute. I've done 2 problems. This working for people, I hope. Now, yeah, someone said just draw the 3, 4, 5 triangle. I absolutely agree with you. But I think it's kind of a cool way. And also, if it wasn't a 3, 4, 5, you could have done this. All right, this is another number 53, another 90-seconder. So let me give you 15 seconds to get an idea about how you would do that one. Okay, that goes by awfully quickly, I understand. Again, I'm hoping my students can do f of g without a problem and set that equal to 0. But just to show a way to do this a little bit differently, and that's again what I'm focusing on, not the algebraic's normal solutions, okay? So I'm going to type in x squared minus 4 into y1 of x, and type in x plus 3 into y2 of x. And then I'm going to do f of g of x in y3, which would be, by using alpha trace, that's where I can get the y variables, and do y1 of alpha trace again to get y2 of x. And I really don't need y1 and y2 graphed. So I'm going to turn those off by pressing enter on the equal sign. And so this is what I've got in my y equals. Let me just double check, make sure I did this correctly. And I'm going to go ahead and graph this. And when I graph it, I can see that this is equal to 0. In fact, I can trace to it. Looks like it's at -1. And I think -5. I could also view the table and see the table that's also 0 at -5 and 0 at -1. So this is the way of seeing it graphically, visually, okay? Um, okay, so Shannon, thank you for saying I can see it. You can visualize it. Good. All right. But again, this is another way students, you can show them that you can do a composition of functions on the calculator, both graphically and algebraically. All right. So on the 84, this is how I did it on the 84, very similar. On the Nspire, this one, I defined the functions. So I think I will show this one because I'm not sure everybody knows about that. So what I'm going to do is define the functions just as they are here. And that's I'm on a calculator page, and that would be menu 1, 1. It's the very, very first command on the calculator menu, 1, 1. And I'm going to define, and I'm going to type in f parentheses x equals, and then I'll type in, as you see it, x squared minus 4. And then I'm going to define g of x as it is there, x plus 3. And then when I go to graph this, let me go ahead and add a graphs page. I'm going to graph f of g of x. Now you'll notice when I'm in f1 of x, when I type in f, notice it's bold because it's been defined. Parentheses, g also bold because it's been defined, of x, double parentheses. So now I can go ahead and graph that. And again, I can see those solutions at -1 and -5. So any questions or comments, Mike, that I should be aware of?
Nothing specific, just all good so far.
Okay, Lori, thank you for saying that was interesting. Glad to hear it. And if I'm going too quickly, you could just put in there, hey, slow down. And if I'm going too slowly, that would be great if you said I was going too slowly. All right, from April of 2022. Oh, by the way, you might want to know what these numbers are. I had put these in some kind of order. I had 30 of them, and I just put them in some kind of order for reference, and then I just cut and pasted out of that. So this number means absolutely nothing. This number means a lot, okay? So here we're solving this log equation, okay? And I'm hoping my students can rewrite this in exponential form effortlessly, but hey, you never know. So for this one here, what I'd like to do is use the, oh, I didn't give you some time to look at it. So let me go ahead and give you a few seconds to look at that one. Sorry.
And while people are reading, Tom, Cindy just had a good question. She asked about your 30, 60, 90. Is that for like a general group of kids, or is that specific to kids that are just trying to earn the highest score?
Oh, I would say for every kid. If you're having trouble with the first 20 questions and you're over 30 seconds, that question you might be better served not doing it, because you're now taking up time that you might be able to do a 60-seconder or a 90-seconder. So now that's not a hard and fast rule, but it's a pretty good general rule. All right, so for this one here, I'm going to use the numeric solver, and I don't like my students to know where that is until we take the ACT or SAT, but so it's under math, and then press the up arrow to get to the last one. TI hit it as the very last one under the math. So there's numeric solver. And there's already stuff there, which I will clear out. And this says expression 1, expression 2, or left-hand side, right-hand side. So I'm going to type in the left-hand side just as I see it here. And so that's going to be under alpha window. And number 5 is log to different bases. So I'll do log to the base 2. And then inside the parentheses will be this fraction. So I'll do alpha and then xt theta n to get the fraction template. Second x squared gets me the radical sign, and I got to put that 3x plus 4 under there and put this all over x minus 2. Enter, and clear this out. And I only need to just type in a lonely 1. So let me see if that looks about right. Type it okay. Yeah, it looks about right. So when you're using something like this, these are the hotkeys along here. And since I want to do okay, that's underneath graph. So I'll press graph to say, okay, I'm ready. And now this is not the answer. This is going to be, I'm going to type in my guess in case there's more than one. I want the one that's closer to a particular number. And since these are all positive numbers, I'm going to pick like 5. I'm just going to pick the number 5 and say, there's my guess. Do not press enter, but press graph to solve it. And when I press graph, I'm getting x equals 4, which of course is the correct answer. Okay. So one of the things I also would want to discuss with students is why A, B, and C have no chance even to begin with. Okay, because you're going to be taking the log of a negative number or 0 in the denominator. So these are your only 2 likely candidates. And so for this one, if I did this one, I would suggest to my students, rule these out, plug in 4, plug in 7, see which one works. Okay. Now, also, this could be done graphically. I will admit that it could be done graphically, and that would be a good one to do. Okay. As far as Nspire to the Nspire users, this is under numeric solve. So if you're not familiar with numeric solve, let me find that for you. So I'll go ahead and add a page, and it'll be a calculator page. And so under menu and algebra, oops, try that again. Menu, algebra, numerical solve is number 6 on my calculator, and I'm using a CAS, by the way. And then I would just type it as you see it, okay? And then it gives me, so now if there was more than one solution, I would have to say, give me one x equals, say, 5 or something like that, one the closest to x equals 5. So good suggestions. I'm glad you guys are putting on suggestions. I like the graphical one, being able to visualize the solution. Okay. All right. So this is from April 2019, number 42. Again, let me give you 15 seconds to get a start. All right, so of course we're going to come up with a system of equations, and I'm going with x is the number of large paint cans, y equals the number of small, and I came up with this system. And then to solve it, in case the students have difficulty solving it, they're allowed to use the solve in the Poly Simultaneous 2 app. So let me just kind of show that there, okay? So second quit, and I'm going to go ahead and run an app, and I'm going to run the Poly Simultaneous 2 app. And I want to do simultaneous equation solver, okay, because that's what I have. And here's what's kind of amazing is the power here. This will solve anywhere from a 2x2 up to a 10x10. Just amazing, okay? And so that's what I want, a 2x2. So I'm going to go to the next screen by pressing graph. And I'm going to type in it as you see here. So I'm going to type in 3, enter, a plus sign, enter, 4 for the coefficient of y, and 68 for the constant, and press enter. And notice that it goes right to where I want it to be. And I'm just typing in coefficients and adding and subtracting signs, okay, which makes this very quick. I love the template. And always encourage your students to double check that they typed it correctly, because they'll just think the calculator never makes a mistake and they'll take the answer, okay? And notice again, I just want to solve this, so I'll press the graph key, and I'm coming up with x equals 12, y equals 8. And you'll notice both of those numbers are there. Okay, so make sure we answer the right question. A small can of paint was x equals 12. Okay. So again, the students have to be able to come up with the system, and if they have trouble solving it, they're always allowed to use this. It's perfectly legal. On the Nspire, this would be under menu, 3 algebra, and then solve systems of equations. And there's also a solved linear system as well. And so here, what I did is I said I have 2 variables, and I put in B and S, which sounds awful, BS, but for big and small, I didn't want to use large and small because my L looks like a 1, and that just doesn't work very well. So I went with B for big and S for small. And oh, you know what? Did I give the wrong answer before? X was large, and I said we wanted to find small. So we wanted small. Yeah, sorry about that. So that was 8. Sorry about that. I had the right answer, didn't interpret it correctly. Okay, so again, that's how you would solve it. Just type it in as you see it. A little bit different look, but solves any linear system. Now, a very similar one from 2023, number 18. I want to look at this one. Just take 15 seconds and look at this. I know it's a lot similar, but there's a reason for this. Hopefully you got to read it and see it's very similar, okay? And then, so how I set this up was I used X and Y and got the equations. I solved it, even though it's very easy to solve it without the calculator, okay? And got 3 and 1. And notice 3 and 1 are answers, but those aren't the answer. It's how much is the cost of a notebook and a package of pencils? So the answer is 4. Again, one of our strategies we do a lot is make sure you don't answer the halfway question, okay? Do all this beautiful work and not answer the question that's asked. And also a linear solve on the Nspire. But the reason I wanted to show this was there is another way you could have done this, and some of you, I'm sure you probably already saw it, and that is if I take this system of equations, I'll take the second equation and write it on top, and I'm going to subtract the first equation. So it'll be minus 2x minus y minus 7. And when I subtract those, I get x plus y equals 4, and we're done. This is a method called using the structure of algebra. And this happens often enough on ACT and SAT that you should consider this as a strategy for solving this. In the materials that we created for the ACT and SAT, we have a section on using structure of algebra. And it's something the students need to learn, okay? And it will definitely give them an advantage. Anybody like this way besides me? If anybody's listening. Nobody listening? Okay. All right. April of 2021, number 59, the second of the last question. Okay. Let me give you 30 seconds to start this one. The structure of algebra is getting some love. Glad to hear it. Glad to hear it. All right, so that was 30 seconds, and I know that's not enough, okay? Um, so I am hoping, well, first of all, I find the other angle, and this angle is 60 degrees. And these are all going to be exact values, okay? We've got 45, we got 60, okay? And we're going to have to use the law of sines. So the length of feet of the string, I'll call that, say, x. And so it looks to me like oh no, length in feet of the string, sorry about that, is x. So that means that the sine of 45 degrees divided by its opposite side is going to be equal to the sine of 60 degrees divided by its opposite side, which is 240. And so it's a matter of me doing that, solve that proportion for x, okay? Now, I did do that to save some time. And just to show the work there, I'm going to get x times the sine of 60 equals 240 times the sine of 45. And then dividing both sides by the sine of 60, I'm getting this. And I'm hoping my students would just put in radical 2 over 2 and radical 3 over 2. But in case they don't remember that, they can use their calculators to type this in. Okay, so I typed in, but I remember I had to be in degree mode. That's a biggie. Make sure you're in degree mode. 240 times the sine of 45 in degrees, divided by the sine of 60. And I got this decimal, which isn't any one of these numbers, but I can rule out C, D, and E. I'm not sure which one these are. So I typed in the first one, and its only decimal approximation is only 103. I typed in the second one, and wouldn't you know it, it was exactly the same. So here I solved it using approximate values, but was able to see if which correct exact value it was equal to. And I'm not sure many students would do that. I think they would just say, oh, I don't remember those exact values. I'm out of luck, okay? Similarly, it would be done on Nspire, same algebra, just type in a little bit different. Again, make sure degrees here. One of the things I do want to point out on changing degrees and radians on here is on this, what you can do is just click on radians and it changes to degrees. So even with your mouse, okay, on here, you can just go ahead that and click on it and it will change to the other one. So really nice feature on TI-Nspire, whether it's CAS or non-CAS, it doesn't matter. All right, let me see what's next. Okay, pause just for a minute. We're a little over halfway through. Mike, anything I should know about?
I think we're good. There was an issue with the chat window, but that was on my end, and I think I fixed that. So yeah, I think we're good.
Okay, and I appreciate everybody's putting in chats. I can't see them all the time because I'm doing other things, but love when you say something positive or even if it's negative. That's feedback I would need to know. So thank you for that. All right. This is from July 2020, number 53. One of my more favorite types of problems. Okay. Again, let me give you about 20 seconds to think about that one. All right, so for this one, I do like the algebraic solution, but let me just show you the advantage, I think, of doing it on the calculator. So let me go back to the main menu and quit this app that I was in before. And again, I'm going to use the numerical solve. So go to Math and up arrow to numeric solve. And I'm going to clear out this side and type in the left-hand side, 27 raised to the, and I can't use x. I'm n. I do have to use x. So I'm going to type in x and then squared. Clear. And then the other one will be 9 raised to the 5n minus 4, which in this case will be 5x minus 4. Again, let me double check, make sure I have that correctly. Okay. So again, I press graph for the word okay. And I need to give it a guess. And looking at what's here, I probably would have guessed the number 4, but let me just pick the number 5 and press graph to solve. And I'm getting 2 for an answer. And by getting 2 for an answer, it rules out the first 4. I really don't need to go any further. However, I did do that. I did go ahead and put in another number. I put in, I think, 1 for my guess, and it came up with 1.333 forever, okay, which would be the 4/3. But again, just by finding 1 and using the multiple choice, I was able to do it a little quicker with the calculator, I think. Yeah, Jay, good to see you, Jay. Nice to see you. Glad you made it. Yeah, Jay said you could both be the same base of 3, and that's exactly how I would do that. But again, that would give me like a 3n squared that I'd have to deal with and factoring and so on. But again, keep in mind, as much as I love the algebra and I want my students to be able to do that, tonight I'm showcasing the calculator. So I don't want you to think I don't know how to do these algebraically. Okay, just so you know. All right, and now on those you're using Nspire. Again, you can use the nsolve as I mentioned before, but when I want to give it a guess, I'll say I want you to solve. Notice I'm allowed to use n also on Nspire, and I said, give me the one closest to n equals 3. Give me the one closest, and I put in n equals 4/3 just because I knew that had to be the solution or close to it. So I put that in, and look what I got. Okay, so be aware of how you could use that on Nspire. Another one with logarithms, solving this one with logs, number 30 on September 2023. I'm number 56, sorry about that. So again, let me give you about 20 seconds to think about that one. All right, now for this one here, again, I could, because we're subtracting logs with the same base, you're thinking division and things like that. But again, I'm going to go back to the equation solver. So I'm going to press the up arrow. And again, I'm just going to type in as I see it. So alpha window is where I get the logarithms to different bases symbol. So it's log to the base 3 of 54. And then get out of that argument. Minus, again, go back to alpha window to get the log to base 3 again of 2. And that will be the left side, or the expression 1. Expression 2, I'll clear and type in log to the base 2 of x. So there's my equation. Let me just double check it, make sure I typed it right. Okay, right bases. And so I need a guess. So I'm going to go with, let me try 10. Sometimes you'll get weird things when you guess things wrong, but let me try guess. Again, not enter. Do not press enter. I can't say that enough. Press graph. And I'm coming up with the answer 8. So, and log to the base 2, of course, of 8 is 3. And hopefully that left side would be equal to 3 as well. So that would be, yeah, log to the base 3 of 27. So somebody said they're still blown away with something, so that's good. So somebody else like to do an intersection of two graphs of two functions? Yep, I'm a big fan of graphs like that. Okay, and also you could even see it in the table. Okay, So thank you for these ideas. Okay. Logarithms are exponents. Yeah, Jay, that was my Algebra 2 teacher said that all the time. He said it several times in the period. So really helped me. And and with Nspire users, I use numeric solve and just typed it exactly the way you saw it, comma X, got 8. I mean, it's just a matter of typing, how quickly you can type. All right, so we're going to diverge a little bit here. This is a problem from 2016. By the way, the December 2016 was the most difficult test on record up in maybe ever, okay, but I'm not sure recently. This is not number 3, okay, it was 30 something, okay, which I think is deceiving, okay. So I'm not so much interested in the answer is coming up with as many different strategies to solve it. So I'm going to give you about 60 seconds to come up with at least 2 strategies. Don't finish solving it, just come up with strategies. Go ahead. Now I realize that's not enough time, so I get that, but I'm more interested in again seeing ways to do this. Okay. And that's what I want you to take away from this, the strategies that you might not have thought to do. Okay. So the first way is the way that I thought of the first time I saw it using systems. So I just said A and B add up to 90, A and C add up to 180, B and D add up to 180. So I have a system of 3 equations, but with 4 variables. And that's usually a problem. Okay. So for solving this, I added the 2 second and third equations together and got all 4 angles adding up to 360. And then I replaced A plus B with 90 and then subtracted that to get C plus D adding up to 270, which is a correct answer. And when I would do this with number 38, and when I would do this with students, they'd go, but you didn't find C and you didn't find D. I know they didn't ask us to, they just wanted to know the sum. And that's not the type of question we ask. And that's how the ACT and SAT are very different. They ask questions very, very differently than we do or our textbooks do. That's why the best practice is to do a problem per day. That's the best practice, and let students come up with different strategies and discuss different paths and so on. All right, so that's one. I love that. Okay, Jay, like you liked it too. Substitute numbers. If Jeff were here tonight, Jeff McCullough. He came up with this one, and I like it. I did not come up with this. So he has the 3 equations here, and he said, but A and B add up to 90. So he said, let A be 20. Just picked A to be 20. And as soon as he picked that, he could find all the other angles. For example, if A is 20, B has to be 70. If A is 20, what about C? Well, if A is 20, C's got to be 160. And if B is 70, D has to be 110. And you add up C and D, and you get 270. Now, you might have students say, but what if I pick the wrong number for A? There is no wrong number for A. You pick A, you find B, you find C, you find D, and then you add them. It will always be 270. You want to pick numbers that are nice. You don't want to pick A to be like 43.5 degrees. That would be stupid. Okay. Third one is draw it. I would have never thought this, but I love this solution. Okay. A and B form a right angle. They're adjacent and form a right angle, let's say. I could extend out that side and get A and C to add up to 180, forming a straight angle, and B and D also forming a straight angle. Okay. And now if I measure C plus D, it's 3/4 of a circle, that's 270. I love that. That's not one, and my students need to see that or share that if they do it like that, because some students will say, well, a teacher never does it that way. It can't be right. Okay. When in fact it is. Okay. I'd hear the people like this because this is my favorite problem, bar none. Okay. All right. So this next one, logic. I was doing ACT training in New Mexico. And after I showed these three ways, a woman came up to me and she said, I use logic. Is that okay? And I said, well, let me know what you mean. She goes, well, A and B add up to 90, so they're complementary. Okay. And so they're each acute angles. So A and B are each acute. Okay. All right. A and C are supplementary. And since A is already acute, C has to be obtuse. With you. B and D are supplementary. B is acute. D has to be obtuse. And so if I add two obtuse angles, the only answer that's possible is J. It's the only one that's possible. Beautiful. Now, some students, are you not using mathematics? We're using logic. We're using mathematics. It's okay. All right. I was in Washington, D.C., doing a talk on ACT at NCTM's a few years ago, and did this problem. And a woman came up and said, I did this using Algebra 1. And I said, I don't think so. But she went on to show me that she did. She let A be X degrees. Now, if A is X, think about how B would be represented in terms of X. And for some students, that's a stretch. It's a teaching thing we need to do. But for us, hopefully you should see that B is going to be 90 minus X. Okay. C, you should be able to come up with fairly easily in terms of X. So C would be 180 minus X. All right. The hard one is D. Now, B and D have to add up to 180, and we've got B. So you got to kind of play around with it a little bit. What do you add to 90 minus X to get plain old 180? And after you play around a little bit, you'll find that 90 plus X is your guy. Okay. Hopefully you'll agree B and D add up to 180. So now that we've got it, add C and D. Minus X and plus X, add up to 0. Bingo. Beautiful. Algebra 1. So I was flying back from somewhere and I said, we got to be able to do this with technology. That's my job. So we should be able to do this with technology. So I took those three equations and I put them into TI-Nspire. And I used the simultaneous equation solver, but I only had three equations with four unknowns. Okay. And so I went to the next screen. And so the first line says 1A plus 1B plus no C's plus no D's equals 90. Next one says 1A plus 1C equals 180. And 1B plus 1D equals 180. So that's my system there. Okay. And so I did solve. I solved that system. And when I did, it came back like this. And most students, when they see this, will go, oh, man, you broke the calculator, whatever. No, when there's an infinite number of solutions, this is how it's done. And it says, remember, these are A, B, C, D in that order. So D is any number. C is this, B is this, A is this. So at first, some kids said, well, I picked 10. If this is 10, then C would be 270 minus 10, which is 260. 260 plus 10, 270. But instead, just add them as you see them. 270 minus x4 plus x4 is good old 270. So I thought that was kind of a cool way. It could also be done on Nspire using the systems of equations. Okay. But again, students need to know how to handle when there's an infinite number of solutions. So good teaching moment here. I was working actually here in Columbus, and a teacher from the Dublin High School, one of the Dublin high schools here in Columbus, did it with a right triangle. It's the last method, by the way. So those of you who are tired of this problem, I'm done after this one, okay? So she started off with a right triangle and said A and B are the acute angles, so they add up to 90. She extended those out and got A and C to add up to 180, B and D to add up to 180. And then she finished off making a trapezoid basically and a parallelogram. I'm sorry, trapezoid rather, where these lines are parallel. And so with the corresponding angles, I get those angle measures. And so we're going to get that A, B, C, and D add up to 360 because they're angles of a quadrilateral. But we already know that A and B add up to 90. So we substitute and we get the 270. It's very similar to one of the other ways, but came across from a very different geometric way. So why teach so many different ways? And I love this quote. I am convinced that students learn in more ways than I know how to teach. And that's why a problem a day, let the kids talk about them and so on. But again, the purpose of this one was strategies. And notice they weren't all calculator ones, because I know some of you were like, he's only doing calculator stuff. Doesn't he know any math? Yeah, he does. He was just focusing on calculator stuff. So thank you for going along with that. Okay. All right. So got 9 minutes left. Okay. Mike, anything I should know about?
No, it's more like 7 minutes, not to
Oh, it is. Oh, yeah, you need, yep, yeah. So you need a few minutes, right? Yes. But no, okay. All right. So here's one. This one I thought was kind of a tough one. Okay. So let me give you about 20 seconds to consider what that one is. And it's hard because you don't have something to write on. All right. So for this one here, one of the things we want to find the length from B to P. So I'm going to call that a red X. And one of the main things is realizing that OA and OB are radii and are equal. Okay. Whatever length this is the same length. So I'm going to call it R. Okay. I also need to be in degree mode, no matter what calculator I'm in. Okay. Now notice they do supply these trig values, but use the calculator. I mean, why would you want to type those in? Okay. So I came up with this, that the tangent of 20 degrees is the length R divided by 12. And then when I multiplied, I got R to be equal to this. And what I did is I did that calculation on my calculator and stored it in the variable R. And I'll show you what I mean in a minute. Okay, but I want to show you the algebra first. And then I'm using the cosine of 20 is equal to the adjacent divided by the hypotenuse, which is X plus R. But remember, now R is a known number. Okay, and so I can go ahead and solve for X. And it is a little bit of a problem to solve for X. But again, notice what I did on the calculator is I am in degree mode. I multiplied 12 times the tangent of 20 and stored that into R. And then when I typed in this expression, whatever value there for R is going to be substituted here, do all the calculations, and come up with 8.4 for the answer. If you're not one person who's used storing intermediate answers into your calculator, whether it be Nspire or 84, I highly encourage you to do that, especially on multi-step problems. It kind of gets to be a difficulty. How you do that would be, I'll just show it like real quick, like say 5 times 6, and then say store into alpha tangent, which is the letter G. And now G has that number 30 in it until I replace it. So I think that's a really good idea to do. On Nspire, it would, again, same idea, only in Nspire. Again, I stored it in a small r, typed in the expression, and let the calculator do all the work. All right, so let me see here. Is there one more I wanted to do? This one, I just really quickly look at this one. Okay, I just typed it in as I saw. on both the 84 and on Nspire, okay? But though it can be done fairly good if you're in good mental math, okay? I do want to show this one before I show you a couple other things, but this one right here, even though it's a number 21, I'm not sure many of you realize you can do this. This can't be done on Nspire, but on the 84, it can be. So on the 84, what I can do is go to y equals, and I'm gonna clear out what's there. And in Y1, I can type in the left hand, type in the whole inequality. So I can type in 3 minus 2x, and then the greater than sign is under test, which is second math. The greater than sign is the third one, 7 minus x. So let me see if I typed that correctly. Did I type that correctly? And I know some of you are saying this is a mistake waiting to happen. I mean, just how could you put in an equal sign with a greater than sign? Not a good idea. Also, it's a good idea if you're using the 84 to turn your detect asymptotes on. I'll explain why in a minute, but I want the detect asymptotes on. And now I'm just going to go ahead and graph. And there's my solution right there. Okay. So what I'm using what's called Boolean algebra. When something is true, it has the value 1. So it has the value 1 right here. It has the value 0 when it's false. So it starts at -4. X is strictly less than -4. So my answer is C.
Hey, Tom,
Yes.
can you run to your Inspire real quick?
Yeah.
This has never happened to me ever in all the years I've known you that I know how to do something that you don't. So I want to make sure all 100 some people tonight know that I got Tom Reardon. So if you go to graph,
A graph screen?
yep, and then just
Okay.
delete that equal sign and go to relation. You can type that whole expression in.
Oh, this can go in there too?
Yep, give it a whirl. Check out what it looks like. I'm gonna give myself a Pez for this one.
Oh, yeah. Yeah. Okay. You're right. It will do that. It will do that. I thought you was going to show me the graph the other way, but okay. Yes. But yeah, I'll give you Pezworthy for that. Thank you.
Thanks.
Thank you. So Inspire users, yes, you could do that if you do a relation. Okay. So Pezworthy, yes, Pezworthy. Okay. All right. So let me finish this up here. Sorry, Mike. We're going to go over a minute a little bit, if that's okay. So my last quote, mathematics is the garment that we continuously alter with our students, and technology should be seamlessly interwoven throughout its fabric. And who said that? Oh, yeah, that was me. So the website has the PDF of the solutions. So if you go there and click on this, you get all the problems and all the solutions as you saw them. They're there. Okay. I do want to put in a plug for a couple of things. One is Jeff McCullough, who couldn't be here tonight, and I are both speaking at Exeter Academy this summer. And I'm doing 2 courses, and Jeff's doing 1. And if you're interested, click that link, and it'll tell you about it. If you don't have money, they have scholarships available. It is like the best conference ever. Okay. No offense to T Cubed or anything like that, but it is outstanding. It's a week-long conference. So if you're interested, just check it out. Just check it out. Love to see you in my class, one of my classes. And then finally, the last thing, I'm looking for a few teachers to help with a new math activity that has multiple solution paths that could be done with geometry or algebra 2 or pre-calculus or calculus on 84 and Inspire. It can be done with and without calculus. So if you would like to do that, contact me with my email address and say, I'd like to do that. And we'll have like a virtual 45-minute session whenever most people can do that. So again, if you could do that, this is the website. There's my email address. And Mike, sorry about going over a little bit, but you got a Pez. So hopefully that covers it.
Thanks, Tom. I will talk fast. So we are giving away to one lucky winner a TI graphing calculator of choice, and tonight's lucky winner is Anne Caraway. So Anne, congratulations. Start thinking about which graphing calculator you want, and I'll be sending you an email here in the next day or so to get some information from you. To receive a certificate of attendance, go ahead and click the link in the chat window. Also listed is a link for the documents for tonight. And if you're missing these for any reason or they're not working, just hang tight. You'll automatically get a follow-up email in your follow-up email, which will contain links to the documents, certificate, and the recording in a couple days. And if you're watching this on demand, copy that link into your favorite browser to receive your certificate. Tom, I made it. My belly's full. Thanks so much, Tom, for everything you shared tonight. Really appreciate it.
Sure, it was fun.
And thanks to everyone who joined us tonight. We hope to see you back online real soon. Have a great night.